Alrighty, and we're back. Before we get on to all about the tides, though, I did go back and actually fix my my headings. That's been bothering me for some time now. Actually, like, why doesn't that look big enough and bold enough? While I was doing that, I actually took a couple moments and grabbed some additional pictures, photographs to put in here, just so, and you don't have to go out and Google yourself. Or for those of you that just wondered what we were talking about. So here's some phytoplankton, highly magnified, of course. Amazing amount of diversity in the miniature world. It's some really, truly beautiful stuff. So there's some phytoplankton. Here are some zooplankton. Down here we got some little guys. They look like copepods, if you would. This guy looks kind of like a baby shrimp. Or it could be crab or lobster in a larval stage. But again, just some beautiful stuff. If you think animals, macro, larger animals are amazing things. The micro world is completely mind-boggling to you. Should be mind-boggling for you. Added some swimmers here. Okay, everyone's favorite sea turtle there, and a lemon shark. And it's bothering me that there's no border here. Sorry. There we go. It's a little bit of border. Yeah, that looks better. So, sea turtle and a lemon shark. What else we got? Okay, so the benthic organisms, I added a couple here. We're talking about barnacles. And I did Google it real quick. I was correct. Barnacles are indeed crustaceans. But this is what you would see. Imagine a little kind of crab guy coming out of there with all his little legs and whatnot, and this opens up and he comes out. And this one is on a crab shell by the looks of it, or what's left of a crab shell. But usually you find them affixed to rocks and boat hulls and pier posts and so on and so forth. This odd little creature here, isn't that cool? That's one of the sea cucumbers that we were talking about as well. Kind of like a slug, not really, but that's probably what, if you just happened upon one, you'd guess. I've always pictured remember those weird little water toys you had when you were a kid? Kind of about the size of a hot dog bun, but it's put together in such a way that it slides very easily through your hands. So I always imagine them sort of the consistency and wriggliness of that, but beautiful critters nonetheless. All right, so anyhow, just patch that up for you, and you'll see that in the PowerPoint that you'll be looking at, I imagine. So now we're shifting gears here again and talking about something that's very vitally important, the tides, and kind of cool to know about. So, as you probably know, the tides are a measure of how high or low the water level rises at the shoreline. High tide, low tide, so on and so forth. Again, it's kind of all important if you're going to the beach, that proper blanket placement, and you want to stake out that turf because you're going to be there for the day, and you want to make sure you don't have to back up, and because you're going to get wet and so on and so forth. That's probably the limit to what many of you have thought about with regard to the tides, if that. Hopefully you also know that the tides are a function of the moon, okay? Gravitational force between the Earth and the moon, all right? And what it does is it actually pulls the water towards it, and it's pretty neat. We're not going to get into the intricacies of it, the physics of it, if you would, but we are going to focus on the different types of tides. All right. Again, you may or may not know that the tide isn't always the same. The highest high tide, the lowest low tide, and then there's the whole spectrum in between. Okay, it's not always the same. So what are we talking about? Well, it can actually be, for those of you that have never encountered this, this is a very drastic example. I showed you, I think back with the seagrass, not the seagrass, the estuary, Chincoteague picture, the difference when the tide goes in and out, okay? And, you know, it results in some muddy spots sticking up out of the water. Well, this is drastic. This guy really needs to think ahead, for example, when they want to take their boat out, okay? Because it's not happening now. That's a big, big, big change. Again, typically not that extreme. Typically not that extreme. So what do we got? All right, we've got spring tide. Spring tide happens during a new moon or a full moon, okay? And you see two examples here. You remember this, hopefully, from when we talked about it the first time. The moon cycles, of course, not tides. All right. Tidal bulge is that area of, as bulge would imply, okay, that area where the water is at its fullest, okay? And what it does is a spring tide compounds the effect. All right, it compounds the gravitational effect. And during a spring tide, we see the largest daily tidal range. Okay, see the largest daily tidal range. A neap tide. A neap tide is at the first quarter or the third quarter. In other words, not new or full. Right? Okay, take you a second to remember that. So first and third quarters of the moon, and you get really the minimal, the least tides here. Okay, and they kind of serve to offset one another. So it's kind of interesting. So you might guess then that this picture, okay, perhaps took place during a spring tide. So we've got neap tide and spring tide as two types of tides that we want you to remember. All right. See, wasn't that complicated, but your book does. If you want more of the details, please feel free to dig into the book, grab the index, and that's actually a great way. We talked about how you guys can go about extracting this material from the textbook. Those of you that like to read it, use these title slides, okay, like tidal slides. Use these title slides in the index. So go into the index and look up for tides, okay, and it'll give you the 1.5 pages, 2 pages in your textbook where it talks about them. Go to niches, ocean niches in the index, and it'll show you what pages those are on, and so on and so forth. Ocean floor, that won't really work with. There's a lot of content in both chapters about the ocean floor. And again, I've just cherry-picked some neat stuff out of it to talk about. So, where's the ocean floor? Well, that's a great question. At some point, you stop being on continent and you start being on the ocean, okay, floor. They are different rock materials. Okay, the oceans are made of basalt, which is a type of igneous rock. The continents are made of granite. However, overlaying all of that, in most places on the planet, is sedimentary rock. Okay, all the products of weathering and erosion, right? And yes, you can get far enough out into the ocean where you don't see that sedimentary layer, okay? It might actually be, well, let me rephrase that, where it is significantly thinner. The majority of your sediments are coming from the continents and washing down into the ocean. You go out far enough, that effect diminishes, okay? So this whole area that we're talking about is called the Continental Margin. Now, this is out of your textbook, okay? Wide sediment-covered areas where the continents are firmly connected to the ocean floor. And that's a great general statement, but I do feel obliged, again, as a geologist, to tell you that there are some areas where that is not the case, okay? The west coast of North America, where we have a plate boundary, or plate tectonics, right? There is a clear division between the continental and the oceanic rock there. And that is an area of great activity. Okay. So, yes, for those of you that remember that and are thinking, well, wait a minute, what about, you're right. Okay. This is just a general blanket statement here. There are areas where that's not necessarily true, but East Coast, okay, you don't have a plate margin until you get way out into the middle of the Atlantic Ocean. And that's something else I realized I neglected to mention in this chapter. Really should at least have, in this lecture, really should have a slide about the Mid-Atlantic Ridge. All right, the giant mountain chain down the middle of the Atlantic Ocean that separates the North American plate from the European plate. Okay, lest I digress, let's get back on topic here, move on. But so this has always bothered me, but it is kind of like right out of your textbook. So, okay, you've heard these words, I have to imagine, before: continental shelf, continental slope, continental rise. All right, and they've always been a little perplexing to me because it takes into account perspective, and you'll see what I mean in a minute. I always think of this as standing on the beach and walking out. All right, so calling the continental rise, that last bit of drop off, as you'll see in a minute, before you head out to the abyssal plains of the ocean. How the hell is that a rise, right? Well, the perspective from that point is coming in from the oceans, you're rising up to the continents, then you hit the continental slope, then you hit the shelf. So in the textbook, they're referencing them from that manner. Not a very humanistic, in my opinion, approach, where most of us, if we have any experience with this, you're standing on the shoreline, you're standing on the shelf. You're going out. Anywho, for what that's worth, if you were confused. If you weren't, I probably just confused you. Sorry. Okay, a lot of words here. I'm not going to focus too much on the specifics here, okay? Don't worry about the degrees of slope and how much of the ocean is actually continental shelf. But the only reason I even care about the continental shelf with regards to this class or my geology class is that during the ice ages, when a lot of the ocean's water was tied up on land in glaciers. Remember the water cycle, right? We only have so much water. So when we made all those glaciers, the water had to come from somewhere, okay? And it was the oceans. So as you see here, we had, in many places, a 300-foot drop in sea level. Now, there's a huge difference here between sea level and shoreline. We talked about this with storm surge way back when we did hurricanes. All right, you may or may not remember that. We talk about a storm surge of 20 feet. That doesn't mean from high tide mark you go in 20 feet. That means from high tide level you go up 20 feet. You turn around, up in the air 20 feet. You turn around and look inland how far 20 feet goes. That's kind of what we're talking about here, except going the other direction. You go from sea level and down 300 feet, and quite often that's a lot more than 300 foot of linear space exposed, if you follow me. Okay? Point being is that during the Ice Age, there was much, much, much more land exposed. And I like to talk about this because it always shows up. It's stuff you guys see, if you're watching Discovery Channel or National Geographic or whatever, especially in the Mediterranean. Okay, but we've got it all around, well, every continent, but North America as well. They find all these submerged cities and villages, and people like to get all mythology about them and everything. And they're like, oh, this is where the Mare people lived. No, this is where normal people lived. It's just that when they built these cities, sea level was a lot lower. Okay. And, it makes sense. It's pretty straightforward. But if you don't know how much fluctuation you can have on the continental shelf, and just like now, people are going to move out as far as they can to be closer to the beach and, the water for food purposes, if nothing else. We built our cities there. And then when the glaciers receded, all right, they were inundated, they were flooded. And this is also important if you believe what I just said, and you've no reason not to, but I'm trapping you here, I'm tricking you. If you believe what I just said, then the corollary has to be true as well. If the glaciers, the ice caps continue to melt, sea level is going to keep raising. Okay, and that's something that folks do have some issue with. And that's what really makes the scientists give you that confused puppy dog look when you say, oh yeah, that makes total sense, but no, not when you go the opposite direction. But yet that's what many people are saying. So sea level rise is a real thing. Do you need to worry about it? Do your your kids need to worry about it? Displacing them? Probably not. It's a slow process. Should we take, steps to prevent it? Yes, don't get me wrong. I'm not saying that. But, if you live, let's say one of you right now lives in Florida, okay, or Maryland, near the shore, is it likely to put you out of house and home anytime soon? No, probably not. We're thinking a little bigger here, okay, a little longer term. But there are certainly places, and Florida is one of them, where you will see that some of these cities are already, being encroached upon. In Europe, okay, tons of places that were built at sea level. Venice, Amsterdam, they're definitely seeing issues already. But so I'm way off topic here, but nonetheless, just don't freak out about it, but certainly consider the implications. The last thing before we leave this slide is I want to talk about the variance. Okay, the continental shelf can be very, very huge in some areas and almost non-existent in others. It's really just a function of how the land was made up. Okay. You'll see a picture when we get to the end of it here. So Continental Slope, not a whole heck of a lot going on here. This marks, if it's known for anything, this is that boundary line, okay, the dashed line where the continent ends and the ocean begins. And the Continental Rise, this is that last bit. Again, if you're walking off of the continent into the water, this is the big slope. You see, we're borrowing that word. This is that big slope at the end of the rise, right before you hit the Abyssal Plains. I want to get to my picture here, sorry, but I do have to pause at the Abyssal Plains. Abyssal Plains, it's just such a cool sounding name. This is the ocean floor proper, okay? And it's the broad, flat area. You're at least a mile underwater, if not 3 or more miles deep, okay? And that's deep. I know you might get in your car and you think nothing of driving horizontally a mile, 2 miles, 3 miles just to go get a cheeseburger or whatever. But think about that going up, okay? Climbing a mile, 2 miles, 3 miles up, how the atmosphere changes. We talked about that back in the weather chapter. Now think about going down, okay? And you have not just the fact that you can't breathe underwater, right? But the something related to air pressure we're going to call water pressure, that the further down you go, the more water pressure you have around you. It's a totally different world. And so you think, 3 miles deep, that's not a lot. well, it's quite different environment. Here's the picture I wanted to get to, and maybe I should just have put it once or twice when we were talking there. All right, so you're going to go all the way back. This looks like the Chesapeake area here. See, this is an excerpt out of the map here. So you've got your land here and what you would call the beach. Any given one of these, you could be here at the beach, you could be here at the beach, here, wherever. Not a big deal. All right, and that is the continental shelf. All right, the Continental Slope, you've got this drop off, and I waited till, there's my mouse. You guys haven't seen me chase my mouse around in a while. A lot of it today. I talked about the rise, and I used the word slope there. I apologize. The biggest slope is right here, and the rise is just that. It's a slow, gentle rise up to the slope. The slope is much more the drop off part. So I apologize for that a moment ago. We talked about the glaciers, okay? These submarine canyons that are near shore, that's results of the glaciers. That's old river valleys that were cut in, or old glacial valleys that were cut in, okay? And now that they're flooded over, inundated, as they say, they're a cool little factor. But if you've studied, read about, watched some of the deep sea stuff, these aren't the canyons they're talking about. We'll see one in a moment. So the Abyssal Plains are out here, and like I said, this is what you would consider the majority of the ocean floor. So I just want to go back to that for a moment here, and a word that, well, it's not exactly commonplace, but you may have heard, something being described as abysmal, right? Oh, that's absolutely abysmal. You might not say it yourself, but you've heard it. That's not a compliment, right? It's like the lowest of the lows. There is another deeper part of the oceans that's called the Hadel Zone. Hadel from Hades or hell, okay? But the textbook didn't really talk about it that much, so I didn't include it here. But abysmal is pretty low, all right? And it's a reference to the Abyssal Plains here. So, speaking of which, in case you were wondering, I know you were, a lot of you have heard of the Marianas Trench, okay? And if you've heard about it, you probably know why you've heard about it. It's the deepest part of the ocean. It's unique, though. It's not just... the ocean keeps getting deeper, 6.83 miles. That's almost, 7 miles, as you're familiar with. It's not like the ocean just keeps getting deeper and deeper and deeper. This is a very special place. We talked about plate boundaries a couple minutes ago, and this is a trench, is a type of plate boundaries, as you hopefully remember. And what's going on here is we have two oceanic plates coming together, forming a trench, and the Marianas Trench is a part of that's actually navigable. Okay, you may have seen James Cameron go down there in one of the last movies he put out, and yeah, Challenger Deep. Here's where it is. All right, and I should have some more pictures in here. I guess I have another job before I post this. He went down there in a little yellow submarine. They had a lot of perils and pitfalls. Google it. It's a pretty amazing video. It's a documentary kind of thing. Don't get me wrong, but the footage is just amazing. And yes, believe it or not, there's life down there. Okay, bacteria, but life. And this is why when people talk about life on Mars, life on Saturn, life here and there, that most scientists don't have much problem, believing that. We know that they're on our own planet. There's life inside of volcanoes, okay, rather inhospitable environment, but we find bacteria living there too. So you're not going to find, little green men bouncing around anywhere, or crab people, or, whatever. Hollywood has led you and sci-fi writers have led you to think about over the years. But life with regard to bacteria, yeah, quite probably. We see it, they're called extremophiles, okay? And we see them in the most extreme environments we have on our planet. So the why not of them being in other extreme environments and other planets, at least in some point in those planets' history or futures, is perfectly conceivable. So anyhow, I will do my best to pull up a couple real photos from Challenger Deep here, get you an actual picture of the Marianas Trench. But that's a great Trivial Pursuit kind of question. So Marianas Trench, plus or minus 131 feet. Yeah, I guess it's really tough to measure down there. And since it is a trench, it's a moving thing. Boy, I'd hate to be down there when the plates shifted. That would really crunch your little submarine. But I think, saying almost 7 miles, I'm okay with rounding at some point. That's impressive enough. 36,000 feet, you could say that. That's impressive enough. My son, he's a bit more black and white. He'd say 36,201 feet. He'd want that in there. But hey, different opinions for different folks, right? And when it comes to test questions, again, I certainly would say Marianas Trench is approximately 7 miles deep, or about 36,000 feet. I'm not going to go in and ask you, is it 6.83, 6.85? Hopefully by now you know that, though. Okay. All right. So that wraps up what I've cherry-picked out of these two wonderful chapters in your textbook. The oceans are amazing things. And they're really, really neat to study, and much of them, if you've heard this before, it sounds like a platitude, but really we've barely scratched the surface of what there is to know about the ocean, not just how it behaves, but what lives in it and how things live in it. Just wide open area of study. So really neat field. All right, folks, take care. Be well.